Hi guys, let's start the next exercise. The next exercise is exercise 1B. So let's look at the concept of irrational numbers. Irrational numbers are basically roots of natural numbers if their exact values cannot be found out, which means root 2, root 3, root 5 are all irrational numbers. 2 root 2 is also an irrational number because the exact value of root 2 cannot be found out. Non-terminating, non-recurring decimals. So, example of a non-terminating, non-recurring decimal would be, for example, 0.4243444546. All this is a non-terminating, non-recurring because there is no element which is recurring in a particular manner. Another example we can look at would be 3.862045192543 and keeps on going. Another example, which is a classic example, is pi. Pi is nothing else but circumference of a circle divided by circumference of a circle divided by the diameter of the same circle. Now this is diameter of the circle. The value is approximated to be 22 upon 7. Please note that this is not the exact value. It is approximated to be or also approximated to 3.14. Next, let's look at some properties of irrational numbers that we already know. Root 3 plus root 5 is equal to root 3 plus root 5. It is not equal to root 8. I hope you remember this property. Next, root 3 plus root 3 is equal to 2 times root 3 and it is not equal to root 6. Please keep this in mind. Root 7 into root 7 is nothing but 7 into 7 within the root, which is root 49, which is 7. You can directly write it as 7. And root 24, if you remember your factorization, then 24 can be written as 2, 12, 2, 6, 2, 3. So this can be written as 2 into 2 into 2 into 3. And out of this, a group of 2, 1, 2 comes out, which means this is 2 times root 6. Right? So we can simplify larger numbers which have some common factors and write them as a simpler irrational number. Good. Let's look at the second part of the exercise, which is representing rational and irrational numbers on a number line. Before we start this, let me quickly go back to Pythagoras theorem that we've learned. Pythagorean theorem states that in a right angle triangle, the hypotenuse square, in this case AC square, is equal to the sum of the other two square of the other two sides, which means it's equal to AB square plus BC square. Now, why am I talking about this? I am saying this because in case you want to plot root 2 on a number line, how would you do that? Now, we already know what a number line is. We've done it for many years. Now, this is a number line going in to infinity on both sides. This is 0, this is 1, this is 2, this is 3. We know root 2 is equal to approximately 1.414. Now, if I have a 10 equal lines between 1 and 2, I can mark 1.4 for sure. But how will I mark 1.414? And that also it's non-ending, non-terminating, non-recurring decimal, which means how would I mark this? That's where Pythagoras theorem comes into play. Now, if I construct a right angle triangle with one side as 1 and the height also as 1, this side, which is the hypotenuse, will be equal to side 1 square, which is 1 square, plus side 2 square, which is also 1 square. This would be equal to root 2. Now, if I measure this with a compass and mark it on this number line using an arc, then from, let's call this point A, let's call this point B, then I would have AB is equal to root 2. Yes, I measure AC and then I mark it on the number line, I will get root 2. This exactly same concept goes on for everything else. If I take root 2 here and I take the other side as 1, then what would be my hypotenuse? Hypotenuse would be root 2 square plus 1 square, which is equal to 2 plus 1, which is equal to root 3. So if I have to plot root 3, then I can look at a right angle triangle with root 2 as one side, 1 as another side, and I would get root 3. Next, the same logic goes here. If I want to take this here root 3 and 1, this will become root 3 square plus 1 square, which is equal to 3 square, 3 plus 1, 4, which is equal to 2. Now to plot 2, I don't need to do all this drama, but I just wanted to understand the concept, which is you can keep taking this, whatever you get, as one side, and the second side always remains as 1. If you want to plot root 5, if this is what I want to plot, then root 3 or rather root 4 here, which is 2, will become one side, 1 will become another side. If I want to plot root 6, then this will become root 5 here and 1 here. This becomes root 6. If I want to plot root 7, then this becomes root 6 here, 1 here, and the hypotenuse becomes a root 7. Let's plot them and this will become even more clear. So this is a question number 5, if I remember. Yes, that's question number 5 from the exercise 1B. And let's look at plotting them. So it says plot root 2. Like I said, we will look at constructing a right angle triangle with one side as 1. I have taken this as 1. The other side also as 1. And then I'll join it with here. Let me see if I can join it properly. Yes, if I join this here, now I write whatever I have. So this is 1 unit. This is 1 unit. So the hypotenuse is root 2. Let's name this point A. Let's name this point B. Let's name this point C. So AC is equal to root 2, but root 2 units, because I have not taken this as 1 unit is not equal to 1 centimeter, because I've taken a slightly bigger graph. So, but since this is not plotted on the number line, I will keep my compass here, measure the length AC, and cut an arc somewhere here. And when I have cut it, I will mark this point as D. Therefore, AD is equal to root 2 units. Please note, I do not have access to a compass on this software that I'm using, this whiteboard that I'm using. So I am not cutting it using compass, but I can tell you once again, you will keep the pin end of your compass here, measure it, measure AC, and then keeping your pin end of the compass at A, I will cut an arc somewhere here, which will define my root 2. Let's look at the next part. If I have to plot root 3, then like we said, then one side will be root 2, the other side is 1. So first we'll have to plot root 2, which means I construct a right angle triangle here. This is 1 unit here, this is 1 unit here. So this is root 2 units here. Now I need to construct a perpendicular. Let's name this again. This is A, this is B, and this is C. So now I construct a perpendicular at C, a perpendicular which is perpendicular to AC and of length 1 unit, approximately like this. And I mark this as perpendicular. This is also 1 unit. I join this point with the original point O. Let's name this point D. And now AD in this question is equal to root 3. Again, this is not plotted on the number line. So now I keep my compass at point A, measure D, and I cut a arc somewhere. Yeah, root 3 is equal to 1.732 approximately. So it would be somewhere here. Let's name this point E. Therefore, AE is equal to root 3 unit. Basic concept is that you take Pythagoras theorem, one side is 1, the other side varies for what you need to plot. Now, if I have to plot root 5, basically I am looking at a right angle triangle with, one second, I need a straight line. So I need one side will be 2 units and the other side will be 1 unit. So this is my root 5. This is 2 units here and this is 1 unit here. So this is root 5. Let's name this point A. This is point B. This is point C. Now when I take my compass, keep the pin end here, measure up to C, and then I cut an arc somewhere here. This point, let's call this D. Therefore, AC is equal to AD is equal to root 5 units. I have plotted it on the number line. If I have to plot 2 root 2, how do I plot it? So I've already plotted root 2 once. I will plot root 2 two times, which means first I make a root 2 here and I join it here. So now what I have here is already root 2. So this is point A, this is point B, this is point C. AC is root 2. Again, I keep my compass at A, measure up to AC, and I cut an arc here. This is point D. So I have got AD is equal to root 2 units. They want root 2 once again because they want 2 root 2. I keep my compass here now and I cut my arc somewhere here. So now let's call this point E. What we have is DE is also equal to root 2 units because I have plotted root 2 once here and once here. Therefore, from the origin, if I look at AE will be equal to 2 times root 2 units. So that's how you would do constructions of 2 root 2 units, 3 plus root 2 units, 3 minus root 2 units, right? So if I have to do 3 plus root 2, I will start the construction from 3 and after measuring root 2, I'll cut an arc somewhere here. Okay, that finishes this video for me. I'll see you in the next video. Take care, be safe, happy learning. If you have any queries, do feel free to write to me. Thank you so much.